you have got sales happening in different quarters. So for sales, what you will have to do is you will first have to calculate the moving total. So the moving total is sum of 4 quarters. All right.
Moving quarter is
The moving total can be for quarterly sales, it can be for yearly sales, for anything. As long as it's moving total, it means that the values being added, they are shifting. All right. So
2 to
for
4 years.
uh, since this is 4-year moving total and 8-year moving average, then we'll take 4 years moving total for one cluster. Then we'll take 4 years moving total for another cluster. So first we did for 2006, 7, 8, 9. The sum of
Yeah.
the sales for these 4 years comes out as 535. Then we did for 10, 11, 12, 13.
No, sir. In the textbook, it's wrong.
Hmm,
550
hmm,
is
hmm.
from 2007 to
From
2010.
2007 to 2007, 8, 9, 10, right?
Yeah.
So yes, so what we have to do is the same way. I think I showed both of you from the other Cambridge book as well,
Yeah,
right?
the Cambridge book.
So from the Cambridge book, it clearly shows that it's these four, then we skip the first one and the next four. So these are the 4 years moving total twice, and then we add the two of them, 550 and 535, we get 1085. That's 8 years moving total. And 8 years moving total, if we divide by 8, we get 8 years moving average.
Sir, can you not do like 8 years directly?
Would be difficult because see this 7, 8, 9, 10, they are being added 7, 8, 9, they are being added twice. So you'll have to do one by one. You'll have to add 4 once, and then, I mean, if you're that good at math, you can do. There is no really requirement to. In exams, for all the calculations that you do, most of the calculations, they are mostly asking just for the final answer, but it is always a good strategy to show all your steps, so that if you get the steps right and you just make an error adding a few things or punching a few numbers in the calculators, you'll still get marks for it.
So why do you skip the first one again?
It's 4 years total, moving total. So each year we calculate 4 years moving total. First we calculated in 2009. So last 4 years are 9, 8, 7, 6. Then when we do in 10, now at the end of 2010, the last 4 years are 10, 9, 8, and 7.
Yeah.
That is why. So each year, since we are calculating this moving total, each year it will move 1 year forward. So 1 year from the last sum, it will get skipped. Understood?
The diagram in the textbook is wrong, by the way.
The diagram is wrong. So for example, what we are doing over here is 130, 130, 150, and 140.
Yeah.
All right. And
that is 550.
that would be 550. And for the first 4 year moving total, we did 125, 130, 130, and 150. Anyhow, once we have got two 4 years moving total, we add them, we get 8 years moving total. And the trend is that you divide 8 years moving total by 8. By the way, if you go with the Cambridge book, it gives you even explanation after this one. How do you calculate trend? What is the seasonal average? What is seasonal variation? But anyhow, that's not included in your syllabus.
So it mentions it on top. It just doesn't say how.
Doesn't say how. That's what I'm saying. The calculations aren't included in your syllabus, but it's there for the Cambridge. Anyhow, doesn't matter if it's there or not. All we need to do. So here they show the correct one. So for example, 4 year moving total is 300, 500, 600, and 550. And then they must have done for 500, 600, 550, and 600. Could you quickly check for the first
I
four?
checked just now.
For these four and the next four. It's
Yeah,
like that.
correct. Yeah.
Mazen?
Yeah.
Okay. And then the 8 years moving total would be the sum of these two. And then if you are 4 years centered moving average, so it's centered, it would be in the, like, the total values that we are using to calculate are 2006, 7, 8, 9, and 10. The middle value is 2008. So this is the trend relating to 2008. Okay, if you want to calculate how much seasonal variation is there, you calculate the difference between the trend and that period's actual sales. So if you
Sir, center, I didn't get that again.
so which values did we add to get this 8 years moving total? 2006, 7, 8, 9 and 10.
Okay,
Right?
it's 5, but yeah.
It's 8, but when we miss the first one, then we do the other 4, and these 3 they are just repeated. So that's
and then
how.
you add
So
both
that
the 4.
at the end of the day, we are just using this 5 years value, 2006 to 10, right?
Okay.
We didn't use 2011's value yet, or 12, 13, 14, at least as of now.
Yeah.
So the totals that we'll be noting would be in front of the middle value, centered. And this is the trend. If somebody asks you that in 2008, how much is the variation from the trend says that 2008's sales should be 525. However, actually is it's 600. So the variation or the seasonal variation in 2008 is positive 75. The seasonal variation in 2008 is positive 75. Actual sales is more than what the trend says it should be. Got it?
Yeah.
Amar?
No.
What does the trend say that the sales should be in 2008?
According to the table or the graph?
According to the table.
525.
What's the actual sales for 2008?
600.
What's the difference?
75.
That's the variation.
Okay.
Alright. And for some periods there would be positive variation, for some periods there would be negative. For example, the very next season, the trend says that the sales should be 593.75. However, the actual sales is just 550 in 2009.
Sir, what's that called when you minus trend by sales?
Variation. Seasonal variation. Got it?
Sir, the thing.
Here it tells you. Actual sales
Sir, the
minus
thing
trend.
I'm confused about still is that you said we have to take the 5 years and then center it towards 2008, but then it's not the correct answer.
It is centered in front of 2008.
Yeah, but
But what?
okay, so but it's not the 5 years. You're taking the 8 years.
We're taking 8 years, but how did we get 8 years? What was the first year in those 8 years?
2006.
Yeah.
What was the last year in those 8 years? 2010.
2010.
So the middle value is 2008.
How is it 2010? I don't get it.
See, what are the first
Because
4 years?
you're dropping one. You take 4 and then you drop the first one and you take the next 4.
Okay.
So first you had 6, 7, 8, 9. Then you had 7, 8, 9, 10.
Yeah, you dropped to 2006.
Okay, I get it.
Okay, and these are the variations from the trend. Here it shows variation would be actual sales minus trend. So this year, for each year you have got the sales, and then you calculate the variation. You can also calculate the average variation. How much is their average variation in particular year? So average variation is all the variations that you have calculated divided by number of variations. So for example, here you calculated 1, 2, 3, 4, 5, 6 variations, right? You add them all up, you divide by 6, you get positive 25. So on average, each year sales, it varies 25 from the trend. Okay, that's how average variation is done for.
It's 27.
It's 27.
Yeah.
All right.
26.6 actually.
All right. Another thing that we have got over here, this is the standard deviation. Standard deviation is how much are the values deviating from the mean value. We have got a mean value, and how much are the values deviating from the mean value. Also for standard deviation we use that. In fact, we're not using standard deviation over here. We are over here trying to calculate the correlation. Correlation is if one value changes, does any other value or does the other variable that we're trying to find a correlation with, does it change with it or not? For example, I'm in the business of selling jackets. Does my sale vary with the temperature that's prevailing in the city where I'm selling the jackets? Is there a correlation or not? So to calculate correlation, I'll have to plot some data. I'll have different values of temperature and I'll have different values of sales. For each temperature, what's the value of sales corresponding, and using that I can calculate the correlation. Can both of you give me one example each of how else or what two values can I find a correlation between for different businesses?
Ice cream temperature.
Hmm.
And sir, I have another question after you answer.
Mazen?
Yeah.
Any correlation that you can say, for example, this is the variable on which sales would depend for any business?
Huh?
Can you find correlation between two variables for sales of a business?
A correlation between.
For example, here you are given the example. We are trying to find out the correlation between advertisement expenditure and sales. Does it happen that if I increase my advertisement expenditure, sales would increase? Or is there no correlation? If there is no correlation, then there is little point spending on too much on advertisement. If there is a correlation, then I would spend on advertisement.
Right.
Make sense, Mazen? So can you give me one more example of a correlation between a business and the sales of a business and any variable?
Mask companies, like COVID masks.
COVID mask companies. What would be the correlation between the mask and? So it could be the number of
virus, more sales.
More virus, more sales. Yes, number of people tested positive and the number of masks sold. Yes, there could be a correlation for that. There would be a correlation for that, maybe. Okay. Yes, Amma, your question was?
Sir, last the extrapolation thing, you didn't give a disadvantage. Give one?
For extrapolation, we have got the disadvantages for extrapolation could be that it is an estimate. It is an estimate based on past.
What is extrapolation?
Extrapolation. Amar, what is extrapolation?
Fancy word for moving average.
Oh, okay.
Extrapolation.
What is that?
Extrapolation is if you have already got some data and then the data it stops, and then if you want to extend the data into the future, you want to like that if this is the trend that is continuing, if this trend continues in the future, what would happen? That is extrapolation. All right. Okay, so for extrapolation, the downside, Mazen, what would be the downside of extrapolation?
It's a prediction.
So,
as you said, so the values are not very reliable.
The values are reliable on the sense that we have been using past data,
and business could go in the same state as it's performing right now.
This is how things have been working in the past. This is how things have been changing in the past. But what's the guarantee that it would continue to happen in the future as well? Any year the trend can break.
Example COVID.
And
like it doesn't take in external factors.
Yes, it doesn't take in external factors. Yes, it doesn't take in. There are too many factors. Unpredictability. The unpredictability in the world. Generally, things are moving. There could be political unpredictability. There could be some natural disaster which could, upset the trend that's been for the way things have been happening.
IT difficulties.
There could be some breakthrough technology that's invented which could change the way things have been happening. Let's say overnight there is some advancement in the metaverse thing that's been happening, and all the classrooms they shift to metaverse. Wouldn't there be improvement in
That's a
the
bit too much.
wouldn't classes be better if they were conducted on metaverse?
Interesting. You would say that, wouldn't you?
All right, all right. So Amar, you got your answer for what could be wrong with the limitations of forecasts.
Yeah.
The other thing is that we are simply relying on the qualitative data. We are less focused on the sorry. We are relying on the quantitative data. We are just ignoring the qualitative data. Then there could be a counter argument to that as well, that whatever qualitative data there is, it, for example, we being scientists, and when we are in the finance or when we are trying to make projections, we try, and this is a tendency that with the advent of science, this is something coming like in our behavior as well. Generally, for all the things which do not have a numerical value, we try to even assign them a numerical value, even for things such as happiness, for example, customer satisfaction, those things. You'd get survey forms which would say on a scale of 1 to 10, how happy are you using our
Yep.
good. 1 would be really bad and 10 would be so a thing which is non quantifiable, we're even trying to quantify that. All right, we
Yeah.
know that this is a qualitative factor, but it would be of little use to us if we just say that we can't calculate it, or we are going to do nothing about it. That, or we can make a crude effort at least to try to bring in some numbers. So the debate goes both ways. They say that qualitative data is missing, and then we say that qualitative data is somehow represented in the quantitative data. Then they would say it's
So
not.
did you fall inside a well?
Did I fall inside a well? Maybe. What?
Okay, you sound like you used to a lot.
I
Can you
suddenly
speak again?
sound like I fell in a well. Let me check if I'm in a well. No, not.
Ah,
Really?
yeah.
Okay, Mazen, did you fall in a well?
Yes.
Okay, okay. The other thing about this forecasting, always there is this problem that whenever there are people, there could be calculation errors. There could be that people who are making the estimates, or who are making the reports, or who are making the projections, they bring
Bias.
their own biases into that research. Or for example, if I change just this, I think that sales, the trend should be 5%. If it's 4.5%, maybe I round things up to make it 5%. And these sort of changes, I mean, these sort of biases or these sort of rounding errors, they can be brought into such calculations. All right. If you are using extrapolation based on a very old data, again the data might be outdated. All right, all right, all right, all right. One more thing, again, something just remotely related to what we are studying right now. There is this book, Thinking Fast and Slow. There were two these Israeli psychologists. Maybe I've told you both separately about those, the Amos Tversky and the Daniel Kahneman. They have one of them then died, and the other one got the Nobel Prize. The research that I wanted to refer to was, there is a thing called law of small numbers. For example, in the previous years, in this book, Thinking Fast and Slow, they have quoted this example. In USA, they tried to find out which schools were doing best. And then they were told that schools with very small pupil number, they were doing best. Some of the schools which were doing best were the ones which had a very small student strength. So they automatically then connected reasons to, they started giving reasons to why that would be the case, because they'd say that students, they got more attention from the teachers and so on. Automatically people would start assigning reasons for that. And then if you ask a counter, and then it happened that it was Gates Foundation and other big organizations which then started funding that schools, they should be built in small sizes. They started providing funding for that, and they I mean, advocated for bigger schools to be broken down into smaller schools and so on. Turns out that if you ask a counter questions, which schools have done the worst, it would also be the
Wow.
schools with small pupil strength. It's not that there is something special about small pupil strengths with regards to the teaching quality. It is that when you have got a very small sample size, it will also always, it is more likely to show extreme values, extreme behaviors. So if you want to get an accurate picture of something, you should feed in more data. It should be based, for example, if I am doing sales forecasting based on just last 4 years numbers versus the sales forecasting that I am doing on last 14 years numbers, the one that I am doing with last 14 years numbers would be better.
Would it though?
It would be. It would be,
How?
statistically speaking.
I don't think it would. Okay.
All right. Then we have got investment appraisal, perhaps my favorite topic. Investment appraisal is how you appraise investments. You have got money, you have got options to invest it in various opportunities, and now you're trying to
Sir,
find.
sir, before we start this, the formula for correlation, what is it?
Formula for correlation is
I need to buy out all the formulas.
this: sigma xy by sigma x squared times under root sigma x squared times sigma y squared.
Huh?
So let's say you have got two variables: advertisement expenditure and sales. Advertisement expenditure, I call it x. Sales, I call it y. Following me?
Yep.
Yeah.
Then for each value of x, I can calculate an x squared. For each value of y, I can calculate a y squared. And for each value of x and y, I can calculate an xy. Got it?
Yeah.
So I do it for all the values of x and y I've got. So eventually I'll have sigma x squared, which is the sum of all x squareds. I'll have sigma y squared, which will be the sum of all y squareds. And I'll have sigma xy, which will be the sum of all xy.
Like I said, there's no way they're gonna make us calculate all, right?
Seems unlikely, highly unlikely,
Okay.
highly unlikely. That you'll be tested on this one is also, I think, a bit unlikely, but you should be prepared.
So
Okay.
from what I've seen, there's like
Is there a
only
past paper question on
one
this?
math question.
There is always a math question.
There's like just one.
Yeah.
Usually there is just one. There aren't
Yeah.
many. You're
And
right.
that one is for you can like you need to calculate like 2 or 3 figures, not like a whole table like this one.
It would never be the case. It would, for even for the sales forecasting that we have done, most likely the way you will get a question is there would be a table, and in that table there would be a few missing values, one or more. So you would be just asked to calculate that missing value. And even if you don't remember the formula, seeing how the other similar values in the same column are being calculated, you can calculate that value as well, even if you don't remember the formula. Knowing the formula is better, but still, there's that hack. Okay. Also for correlation, I didn't mention that if correlation is positive one, it means things are positively correlated. If one thing increases, the other would increase. If there is negative one, it means there is negative correlation. If one increases, the other would decrease. If it is zero, then it would mean there is no correlation. If one changes, the other does not change.
Okay.
All right.
How do you use the formula?
We use the formula that I told you. We calculate the values of x squared, y squared, and xy, and then we plug it into this thing. R is equal to sigma xy, which in this case will be 102.28, divided by under root sigma x squared, which will be 81.93, times sigma y squared, which will be 173.18. You'll get a value of R.
Indeed.
Got it, Mazen?
No.
No. Did you get it? What I meant by sigma x squared, sigma y squared, and sigma xy? Did you get how I got these?
Yeah.
Are you sure?
You added the
We first calculated the x squareds, and then we added them. We calculated y squareds. We added them. We calculated xy. We added them. Then we are just using these values and plugging it over here. Sigma xy is what? 102.28. Alright? Sigma x squared over here in the formula, it is what? 81.93.
Yeah.
Sigma y squared in the formula, it's 173.18. So you just put these values over here. It's shown over here. And then when you solve it, you get a value of R correlation, which over here says 0.86.
Yeah, okay.
All right. Is 0.8, then first of all we have got no correlation, which is 0. We have got a positive correlation, which means if one increases, the other also increases. We have got a negative correlation, which is inversely proportional. One increases, the other decreases. And then even we have got strong correlation and weak correlation. If the values of R, absolute values of R, are less than 0.5, it's a weak correlation. For example, if I get the value of R equal to 0.4, 0.3, 0.25,
then it's weak, right?
It's weak correlation. If I get a value of R over here, for example 0.86, then it's like a strong correlation. So these two values shown over here, this is a positive correlation but a weak one.
Right.
This is a negative correlation but a stronger one. The trend line is easier to plot over here. So there is a stronger correlation between unemployment and quantities of sofas sold. Unemployment decreases, quantities of sofas sold increases.
How?
People are now employed, they have got more money to buy sofas.
Oh, okay. More employed, more. Okay.
Unemployment decreases, quantities of, and here the marketing expenditure and quantities of sofa. If they increase the marketing expenditure, yes, the quantity of sofas sold increases, but not that much.
Right.
All right. So the stronger indicator for their business is unemployment as opposed to their marketing expenditure. Could tell that their marketing efforts so far have been not good.
Right.
If they improved their marketing efforts, they were undirected, they were unfocused. If they had better marketing plan, maybe the quantities of sofas sold would improve. Okay, so it also then, so here you have got no relation at all between quantity of baked beans, like sold or bought or what, and quantities of sofas sold. There is no correlation.
So you can even tell from the graph, right? Like all over the place.
Yes. That's what I've just told from
I
the
don't
graph.
think you need a graph for that.
All right. Okay. Correlation. There is just one tidbit before we move forward. There is one more thing, which is correlation and causation. Correlation does not necessarily prove causation. If one thing increases and the other increases with it, yes, there is a correlation. But did the increase of the first cause the increase of the second? Not necessarily. For causation, you have to do some more calculation, more rigorously, and to prove that the second one was indeed caused by the first one, change of the first one. Got it? So, for example,
but it's not in our thing, right?
It's not there in your tables, no.
Okay.
On to investment appraisal then.
Yep.
So investment appraisal is, I've got some money, I can invest in various opportunities. How do I determine which opportunity is the better one to invest my money in? The methods that I use to analyze the investment opportunities, which investment opportunity is better, is called investment appraisal. We need to know how these methods work and what's the limitation for each of these methods. All right, Mazen?
Yeah.
Okay. Who can tell me about payback period?
Payback period is like how long it takes to pay back the liabilities.
Make break even.
Sort of to break even. It means net payback or payback period is how long. If I've invested money in a project, it means there has been cash outflow. When I invest money in future periods, there is going to be cash inflow as a result of that. Okay. When in what period of time or when, at what point of time will this cash flow become zero? This net cash flow becomes zero. The money that has gone away from me and the money that has come back to me, it becomes just zero. So for example, see this various projects over here. The first one, they initially spent 70.
Yeah.
Then in year 1 they get 10 back. 10 positive means inflow. So it means at the end of year 1 their net cash flow for this project is negative 60. Then it becomes negative 50. Then it becomes negative 30. And then it becomes negative 10. And then it becomes positive 20. In year 5 it becomes positive 20. So after the end of year 4 and before the start of year 5, there must have been a point where this cash flow it became zero.
Right.
Did you get this, Mazen?
Yeah.
Okay, so what exact time in above year 4 did I need to make this cash flow zero is, it was negative 10 over here. So the additional amount that I'm getting in this year, the amount that I need to recover, for example, last year it was negative 10. So I need 10 more. So 10 over 30 into 12. 10 over 30 is the fraction of amount that I need from this year 5's amount.
Yes, okay.
Alright. And then 10 over 30 into 12 would be multiplying it with the number of 12, so I'll get the answer in terms of number of months.
Yeah.
Alright, similarly for the next one, project A, yes, here they have been showing the, I just didn't see these cumulative cash flows before.
Sir, is it multiplied by 12 or divided by 12?
Multiplied by 12.
How?
The same way, if you wanted to calculate percentage, would you have divided by 100 or multiplied with 100?
Yeah, but here it's there's 12 months, right? So 30 divided by 10 is 3. And then 3 divided
10 divided by 30. 10. The amount
10
that 10 divided by 30 into 12.
Okay.
1 over 3 into 12 or 12 by 3. Alright, same for the next project. Initial outflow was 70. Then first year they got 20. The cumulative cash flow became negative 50. Then it became negative 30. Then it became negative 10. And this year it became 10. So in between this negative 10 and positive 10, there would have been a time when it was 0. So 10, negative 10 divided by 20 into 12. That will give you 6 months. Mazen, are you following this?
Wait, repeat.
This negative 10, the last negative cash flow.
Yeah.
Last negative cumulative cash flow divided by the next year's cash inflow.
Yeah, okay. Times 12.
Times 12. You get 6 months.
Yeah, okay.
So same over here for this project.
For project C, you take negative 10. You take 10 over
20 again.
Times 100.
Times 12.
Oh yeah, times 12, yeah.
So you'll again get 6 months. So how do we use the payback period? For payback period, we say whichever project has the shortest payback period time, that project is better.
But what about expected net cash flow? Doesn't mean that because payback period is fast that your future profits will also be a lot. Again? Just because your payback periods are quick doesn't mean that your profits, like some companies.
That's the shortcoming of payback period method. That's the shortcoming. But if we are evaluating using just this payback period, then we'll always choose the project based on this technique. Based on this technique, we will end up choosing the project with the lowest payback period, and the limitation, as you just mentioned rightly, that it might not always be the best one for the business to choose for some reasons. And that is why when we have learned about all of these different methods, we would say that for a business to make good decision, they should not be relying on just one of these methods to make investment decisions. They should perhaps be using a few techniques together to analyze which project is actually better for them. If you, both of you could quickly go through this chart, and if you have not already, maybe take a screenshot of it, save it somewhere as well, read it, memorize it. Done?
One second. Okay.
Mazen?
Yeah, just 1 second. Yeah, done.
Alright. Okay, the next technique that we have got is accounting rate of return. Accounting rate of return we calculate by, first of all, there is this formula, average rate of return or accounting rate of return, net profit per annum divided by capital outlay. So how do we calculate the net profit per annum and how do we use the capital outlay? So here we have got three projects. The first project, the initial cost that we have to invest in this particular project is 50,000. So that is negative 50,000. And then for the years to come, you will have positive cash inflows.
Yeah.
Alright. If you add all of these, positive and the negative ones, you will have net profit for the project. So the returns that you got in this project, for example, if you have got calculators at your hand, quickly do the sum. Minus 50 plus 10 plus 10 plus 15 plus 15 plus 20.
Plus 20, yeah.
How much did you get?
That's 20,000.
20,000. So that is the net return on this project over a period of 5 years. If I divide it with 5, I'll get yearly return. So yearly return is how much? 4,000. 4,000 over initial investment. So for this 50,000, I'm getting 4,000 return per annum. So my average rate of return is how much? 4,000 over 50,000.
So can you repeat what you just said?
Oh, okay.
Okay. See, this is the initial cost that we have to invest in the project, 50,000. So this is outflow, this is negative, right?
Yep.
Then for these next 5 years, it generated these cash inflows. So negative 50 plus 10 plus 10 plus 15 plus 15 plus 20. You'll get positive 20. That is your net return from this project.
Okay.
That net return of 20,000 was earned in how many years?
5.
5, yeah.
5 years. Per year, how much did you earn?
4.
4,000. You earned this 4,000 over what investment?
50,000.
50,000. So if you divide this annual return over the investment which helped you earn this, you will get the rate of return. So this How much is it?
A lot.
It's not a lot.
Little?
Do the calculation. Tell me the amount.
It's 4,000
over 50,000.
over 50,000. I get 0.08.
0.08, or you can say 8%. 0.08 multiplied by 100,
Yeah.
you get 8%.
Yeah.
Got it, Amar?
Yep. But do we use the 8% as what is that thing on top?
Average rate of return. Average rate of return or annual rate of return.
And then you do it for all the projects and then see which one is the highest.
You do it for all the projects. So
okay, sir, what is capital outlay and what is net return per annum?
Capital outlay is this 50,000, the amount that you initially invested. There is another formula as well, but it's not there in your course. In your course, it's simple. It's just the initial investment that's required to be made for this particular project. Okay. Otherwise speaking, it's inclusive of, for project you buy machinery, and that machinery at the end of the project, it has a certain disposal value. So when it says capital outlay, it means the disposal values, all those things, they have been adjusted for. This is the net investment that you have to make in this particular project.
Right.
Okay. So that is the capital outlay. The net profit per annum is you take the total cash flows for the project, positive, negative, everything. If you add them all up, cumulative cash flows, they give you total return for the project, net return for the project. But that net return for the project is over the life of the project. The project may have 5 years life, 6 years life, 10 years life, 20 years life. So if you add all the cash flows of the project, they give you the net return of the project over the life of the project. Then you divide that net return by the life of the project, you get yearly return.
So this is too much.
It's simple.
At once. I think.
All right. So here, the total return that you earned for this project is how much? 20,000.
I got this.
You divide it with life. You divide it with the period of the project, let's say.
Right, I got that.
That is your annual return.
Yeah.
That's it.
Okay, that's what you were saying.
The annual return is, average annual return is 4,000. You divide it with, over the capital cost, you get return on your investment that you have made.
Sir, the cash flow, net cash flow, it says 70,000 just in this thing. What is that?
It's a bit deceiving in the way that these net cash flows, they are just the sum of returns. Year 1, 2, 3, 4, 5. Actually, net cash flow should mean they should have net the initial outflow as well. They haven't done that. They have just added the returns that they have earned.
No, so we should have just done 70,000 minus 50,000 divided by 5.
No, 70,000 minus 50,000 is net cash flow.
Yeah, and then divide by 5 for getting
annual cash flow. Yes.
Yeah.
Average annual cash flow, and then that average annual cash flow over the investment that you made, you'll get the rate of return. 8%. So quickly, if you could, looking at the screen, if you could do it for project Y and project Z, and we'll match with the values that are given over here. Let's see if you do these right.
Okay.
Meanwhile, I'll have some soup.
There's no time for your soup. It's 10% for Y. Okay, so it's 10% and 8.9.
Roughly 9% for Z.
Huh?
9% for Z.
8.9. 8.88888.
Mazen?
So I'm showing all my work and doing the most. So give me a minute.
All right. Mazen says have some soup.
Why are you letting Sir drink soup? I don't get it. Sir, give me 2 minutes and I'll forget all this.
All right. So here's your answers, which Mazen will get in a minute. So since you have got hang of this thing, in the meanwhile you can go on to read this.
So I put so much working I forgot what to even do.
Story of my life.
Okay, first you add the.
Amar, tell him.
Okay, so you see the total net cash flows.
Yeah.
So for project Y it's 60,000 and then capital cost is 40,000. So you subtract 40,000 from 60,000, you get 20,000, and then that value you divide with the amount of years, which is 5 years, you get 4, and then that you, what do you do with that, sir? That
Multiply by 100, right?
yeah, multiply by something like that. 60,000 minus 40,000
20,000.
will give you 20,000.
20,000 divided by 5.
Divide by 5. Divide
4,000.
by 5 is 4,000. 4,000
over 40,000.
divide, yeah.
Annual profit divided by capital cost or capital outlay.
Yeah, so 4,000 divided by 40,000, which is 0.1. That multiplied by 100, which is 10.
Okay, I got it now.
The same way for Z as well. Z, Z, whichever.
Z.
Alright, we move on to this. Take a mental screenshot. Mazen, what did you tell me? You're doing HIFs or have you completed it?
Huh?
What did you tell me about your HIFs? Have you completed it or is it still in progress?
No, I paused it. It's on hold now. Because exams. What about you? Are you still doing the online course?
Oh, it's in progress. I had a deadline for writing that research paper that I was supposed to write. The last day I tried writing.
Words?
It's not 3,000 words, it's roughly 20 pages. They haven't specified a word count really. But then I started writing it and then I couldn't, and then I suddenly watched the group. They said that the deadline has been extended to 7th January. I said yes. Yeah. And since then I haven't written a single word.
7th is in like 5 days, right?
4. Quick math.
So every day I
I said
say
5 and it's actually 4.
It's 3 almost.
It's 3?
I mean,
it's 4 days.
yeah,
Seventh is also included. So by seventh midnight, I mean
yeah.
seventh ending, I have to submit it. So each day I say tomorrow, and I mean each day I divided that. All right, 4 days left. I'll do this part this day, this part this day, this part this day, this part this day. Then the next day I reassess how much is left and how much is to be done. I redivide the tasks until the last day comes.
Mhm.
Oof.
So can you explain this?
All right. The good thing about average rate of return is that it uses all the cash flows of the project. Remember the payback period. In the payback period, we just stopped at the cash flow where the it paid back for the project. We didn't go any further. We didn't say what would happen after that. In this particular method, we are using the cash flows for the whole project. All right. In the payback period, again, there was a shortcoming, as you mentioned, that doesn't necessarily mean that the project which pays back the quickest is also the most profitable one. In fact, the profitability was never discussed over there. Here, we are discussing the profitability of the project. And
Right.
businesses, they are usually motivated by and influenced by
So,
profitability.
that percentage, it's per year. Like you get 8% profit per year.
Hmm.
Okay.
Hmm. Hmm. Because we are using the per year profit over the we divided that over the capital investment for the project. Okay. Similarly, it's easy to explain to people that this is the profitability. People have a sense of what profitability is, and it's easy for them to compare the profitability of other projects and to obviously make sense the project with the largest profitability. That is the one that should be pursued. Similarly, in terms of percentages, it is easier to understand like how much percent is the return on a certain project. Then it can be compared with the benchmark rate of the business as well. For example, if the business has a policy that they wouldn't invest in a project unless it gives X percent of return. For example, the business might have a policy that they won't invest in a project until it gives 20% return or 25% return. Okay, so that percentage can be compared with anything. It can be compared with the other projects as well as these internally set benchmarks by the business. Understood?
Yeah.
The main problem with both the payback period and the average rate of return, in fact, it's one problem which has been broken down into 3 points, and that problem is time value of money. We are assuming that the money, for example, in this project, the 15,000 which is earned in year 4 is the same as 15,000 which is earned in year 3. In fact, the amounts which are earned in year 5, they are.
Inflation. Inflation doesn't take.
Inflation, the erosion of the value of money, that isn't taken into account.
So, but you can use that for like any, right?
For the net present value,
None of them have
for
discount.
net present value, it cannot be said. For net present value, you cannot say that.
Sir, give me 1 minute.
Okay.
Hmm. Because net present value, it uses the time value of money.
Yeah.
The payback period and the average rate of return, they have this shortcoming.
Oh, okay.
Have you gone through this one? This chart?
Yeah.
Alright. Let's wait for Amar to come back and then we'll move on to the next one. Didn't go to school today, or did you?
Online.
Online. Oh, I didn't ask. Did you have online classes like before in this? Have they said anything about the exams?
Yeah, they sent an email that it'll carry on, and you need a 96-hour PCR test.
Okay. Okay. How many PCR tests have
But
you
I'm
had so far?
sick. I'm sick now, and I don't know if I have COVID or not.
Mm-hmm.
You
How many
know,
how many times you have had PCR tests so far?
wow. Over
Okay, I
like
just came back. What up?
40 times. A lot.
How many times
And
have you
they're
had PCR tests so far?
Uh, uh, 3. Yeah,
3 tests?
yeah, just 3. Which school do you go to?
Cambridge.
Yeah,
I
And you're
haven't
in
had a
Dubai, right?
single one yet.
yeah.
You have
Interesting.
3 different categories here. You have Abu Dhabi, they care a lot about COVID. You have Dubai, they're
Hmm.
like, eh. And you have
Correct.
like
Yeah.
Pakistan and like,
My cousin, he lives
this
in
is
Abu Dhabi. He came here last year. Does he live in Abu Dhabi, Dubai, somewhere? And he told me his
I know
kids,
he's
they
in
are,
Abu Dhabi.
his kids, they are like a few years old. And he said, pointing to his child, he has had his PCR test 5 times. That
that's
was
definitely
last year. Huh. Abu Dhabi, they come
How?
knocking to their homes and they give them vaccines and everything.
yeah.
I mean, it's not a bad thing if you think about it.
Yes,
Because
but
over here in Dubai now the cases are increasing.
hmm,
Hence, we have to go. We have to do homeschooling.
hmm, hmm, hmm. Good for online teachers, anyhow.
That's what I
Okay.
say.
Okay. So the main problem we have had with the techniques that we have discussed so far is the time value of money. So what is this time value of money and why not bring this into play? Okay, so time value of money is where you have a rate of discount which you'd use for a particular year. Most probably, you will be given this rate of discount chart in your exams because that is how they have been using it. Even if you are not given, shall I tell you how to? I've already told you both before how to calculate this thing, right?
I don't remember.
1 over,
Neither do I.
okay, okay. So for example, let me tell you how we got this value of 15% for year 5. Take out your calculator, write fraction 1 over bracket 1 plus 0.15 bracket close raised to the power 5.
0.49.
7176.
Here 0.5. Okay, so the formula is 1 over 1 plus I percent, the interest percent, bracket close, raised to the power n, which is
Okay,
this.
relax, sir. Okay. What?
1 over
1 over
bracket 1 plus I,
bracket 1 plus
Okay, what is the I?
I.
interest rate or discount rate.
Okay.
1 plus I
And what is
percent,
N?
n is the number of periods. 99% chance you wouldn't have to resort to calculating these discount rates. Even in Cambridge, they're given.
Hmm. It's not in our textbook, right? The formula.
Mhm. It's compound interest formula. It's grade 6, 7 math.
Ah, interesting.
And I don't even know it. Great.
Never heard of it.
I've never seen this before.
All right, all right. Okay, so the way we use it is, for example, for any given question, we would be told the respective discount rate applicable. For example, it would be said it's 5%, it would be said it's 15% or 20%, and then throughout that project for which it is said that it's this percentage, we'll just be using that particular column. Okay, so for year 1, the discount rate is always 1. For year 0, sorry, for year 0 the discount factor is always 1. For year 0 discount factor is always 1. The reason being 1 plus I raised to the power 0 will give you 1.
Yes.
Okay, and it also makes sense that discount factor is, you're saying that this value in future is inflated, if I bring all these values to the present time so that they can be added and they are like of equal buying power, equal purchasing power, equal time value, so the value that is here right now, it need not be taken anywhere. This is like at present, this is the value. The present value cannot be further discounted back into present.
Past?
Past we aren't interested. Okay, so here we have got an example. We have got a project, and for the project we are given the cash flows. That is the information that you will be provided, and then you will be provided a discount rate that you'll have to use. For example, in this particular case it says 20%. So what we will have to do, if I go back up to this chart, year 0 value I'll have to multiply with 1, year 1 value I have to multiply with 0.83, year 2 value I'll have to multiply with 0.69, year 3 with 0.58, and so on. For each year's value, if the future value, if I multiply with that year's discount rate, I will get the present value. The values which are given, we'll simply multiply them with the discount factors and we'll get the present values. So over here, this will be multiplied with year 0's discount factor, year 1's, 2, 3, 4, 5, and so on. So the discount factors we are using is 0.83. So if you could check a few of these values over here. For example, this 3300, how did I get it? I took this 10,000, I multiplied with year 6 discount factor of 20%.
Okay.
Which is 0.33. So it becomes 3300.
What is discount table rate of discount at 20%?
These are discount factors. This is the same 20% column copied over here.
Okay.
This same column.
So you go 1 over bracket 1 plus
I percent raised to the power n. Don't focus too much on that formula. I just gave you just in case. Most likely it won't be used in your exam.
Right.
You don't have to use it.
It's 1 plus the discount rate, right? Okay.
Raised to the power n.
And n is number of years.
And discount factor, remember to use it in decimal form, not in the percentage. For example, 15% will be 0.15, 10% will be 0.1 in the formula that you're using. 20% will be 0.2. Don't add 1 plus 20. It will be 1 plus 0.2.
Okay.
Okay.
Alright, so let's see if you could check these values for present values for project B and let me know if you get them right. Or do they have a question on this one? Do they have a question on this one? They don't. You'll have to check these. Year B's future, these are called future values, the values which are given for the project, that in year 1 I'll get this return, in year 2 I'll get this return, and so on. These are future values. I have to discount them back to present, and in order to discount them I have to multiply them with their relevant discount factor.
Okay, you just have, what is this? Like, this is all you have to do?
This is all you have to do. You get all these present values, you add all the present values, you get net present value.
Yeah.
No, but they did something. Okay, they subtracted present values with the
initial investment, initial outflow. That is year 0 value, so that is also the present value, and this is the I mean the thing about this book that irritates me. When they say net cash flow or present value, it means it should be all. It should be sum of all. But here at least they have mentioned present values for year 1 to 10. It means they haven't included year 0.
Right.
Do it for project B and C and let me know if it makes sense to you, then we'll move forward.
Sir, these values are rounded.
These values are rounded.
Yeah, I think, yeah.
Yes.
It won't give me an accurate number then.
Don't calculate these discount factor values. I'm repeating again and again. Most probably you'll be given these.
No, sir, I did 20,000 for project C.
Multiply by 0.83.
It's 16,600.
16,600 shouldn't be rounded to 16,000.
Yeah, I think that 0.83 is rounded.
Yes, 0.83 is rounded. Let me check. Where's my calculator?
Oh, sir, you don't trust me putting in numbers in a calculator, I see.
I've been getting a lot of these trust related remarks these days.
Trust issues.
1 plus 0.2 bracket close raised to the power. What is this year? Year 1?
Yeah.
16,666.66667.
See, what did I tell you?
Wow. Mathematician.
Wait, can you repeat again? What did you do? 1 over.
What we should be doing is 20,000 into 0.83.
Are you using the equation, the formula?
Just leave whatever he said. Just do 20,000 into 0.83 and 16,000 into 0.69, so on.
8 years cash flow which they have mentioned, multiply it with that year's discount factor.
So what's the formula there for?
Which formula? The formula that I told you.
Over 1 plus.
To calculate the discount. In case they just tell you the discount percentage and do not give you the table, that formula is there to calculate the table.
Oh, I've been using that too.
So why did you do this?
I'm just thinking, why did I do this?
Yeah, you didn't have to give it, did you? Yes, sir, what are the advantages?
Mazen, shall we move to the advantages or are you still figuring this thing out?
Can you do like a different year?
Alright, for year 4 it will be 12,000 into 0.48. For project C, year 4, it will 12,000 into 0.48.
5760?
Yeah, it's given in the table.
Here, 5760.
Oh, okay.
Then for year 5, you have to do 12,000 into 0.40.
And if the discount rates are not given, you use the formula.
The discount rates will be given. Discount rates will be given.
Like the table.
It will be given. Yes, if it's not given, you use the formula, but it will be given.
Okay. Got it.
Okay. On to advantages and disadvantages of NPV.
So can you explain?
So the first thing that we have been crying about, I'd say, the timing of the cash flows. That problem is removed over here. We have considered the timing of the cash flow. We have discounted the cash flows with the relevant values, with the relevant discount factors. Okay. Similarly, there is a problem with the net cash flow, net present value method, that throughout the project we have assumed that the discount rate would remain 20%, whereas in practice this discount rate would vary uh, due to varying economic circumstances. Practically speaking, the discount rate, it does not remain the same constant standard throughout for 5, 6, 7, 8, whatever years.
Right.
All right. So then there is the problem with this net present value method. This problem can be slightly overcome by using the same model with different discount rates. For example, I've got a project. I will say, what if the discount rate becomes 20%? And what if the discount rate becomes 15%? So then I can run both these scenarios and I will know that it would be at best in between these two extremes. Because I calculated the net present value for the project using different discount rates. Okay. So these discount factors, they sort of give you in a way the opportunity cost for the money, that had you not invested in this particular project, you would have for example, invested this elsewhere. What would you have earned had you invested this elsewhere? What additional amount are you earning through this project if you invest in this project? It's automatically. For example, see this. The net present value for this project B, it's coming out as 7190. It means that if I had just invested in an interest bearing instrument which would have gave me 20%, I would have avoided this loss. If I'm investing in this project, I'm losing in fact 7190. It's better to just let this money be invested in some fixed deposit and I'll earn better return over there. Alright, so this opportunity cost is sort of inbuilt in this net present value. The other problem, the main problem with NPV is that it is reasonably complex, as I can hear from your voices. And then it depends on the discount rate used, which may be varying. It only makes sense to compare the net present values of different projects if their initial capital cost invested is the same.
Right.
If initial capital investment isn't same, then it wouldn't be as meaningful to compare the net present values of the different projects. That's it. Here is a question for you. Here is a question for both of you. What were the downsides of payback period?
Profitability was not taken into account.
Okay, what else?
Time value of money wasn't taken into account.
Excellent. Time value of money wasn't taken into account. What if, here I have got this project A, these are the cash flows for project A, and these are the discounted cash flows for project A. What if I calculate the payback period for project A using these discounted cash flows? Would it solve that problem that time value of money is not accounted for?
Yes.
Mazen?
So you're using both methods?
I'm just using the payback method, but the cash flows that I'm using are the discounted ones. Discounted cash flows I'm using, not the actual cash flows. So yes, it would overcome that problem that time value of money isn't taken into account. And that is sometimes what we do. So for example, these projects I know even at the end of their life, since the net present value is negative 8300, this project even it won't pay back even in 10 years.
Yeah.
Whereas if I were doing the simple payback method, I'd see that this project it pays back in 5 years.
So what is this called, this new method?
Discounted, this method, like the method that we whole discussed, this is net present value. But if you use the payback period using discounted cash flows, this is called discounted payback period.
Yeah, this. Okay.
All right. This
So you're
project,
basically using both, right?
we are using a mix of the two.
Discount of the
Discounted
net
cash
present value
flows.
and the method of payback.
Hmm.
Okay. It's called discounted payback? Discounted.
Payback period. So project A and B, they wouldn't pay back as per discounted payback, discounted cash flows even with 10 years, because at the end of 10 years they have got negative net present values. This project C would. And if I were using the simple cash flows, then all three projects would pay back within this 10 years lifetime. All right. All right. Now, having discussed all of these together, the whole different methods, the three different methods that we saw, what are the downsides of all these investment appraisal techniques together? If you could make some critical remarks on them.
Time consuming, values might not be accurate.
External factors.
Why values might not be accurate? What external factors, for example?
Like legal problems, natural disasters. Yeah, pestle. Yeah.
All right. So the circumstances that we are assuming constant for the project, for example, we are saying that the project we are trying to project into the future. We are saying that in future we will have these cash flows. What's the guarantee that we will actually have these cash flows? All right. We are saying that we'll have this much discount factor. What's the guarantee that the actual discount factor will be this much? Okay, we are saying that we'll get these cash flows at this particular period of time. What's the guarantee that we will get it on that particular time and not after that or before that? That will change our assessment. Secondly, we have seen that all these different techniques, they show a different aspect of how a project can be evaluated, how a project can be appraised. For better decision making, we do not rely on just one technique. We use two or three or as many techniques as possible together. We do all the analysis on the projects and then we try to come up with a conclusion. The third thing, obviously, the qualitative factors. For example, there is a certain project which is, let's say, highly profitable, but it could lead to negative connotation by existing customers on our portfolio. It could lead to legal problems. Its cash flows, if they come true, they are highly profitable, but it's risky, they might not come true. All right. So these qualitative factors, they are usually absent. We are just for example, giving a verdict based on the numbers that are there before us. Okay. If you could quickly read this investment appraisal final evaluation, there is here and on the next page as well. Then we'll move forward to the next thing, if there is any today.
Uh,
Done?
Yeah.
Done?
yeah.
Mazen?
Yeah.
Decision tree. Do we do decision tree today? Let's do decision tree today. Okay. Decision tree is where you have got the you have to make a decision, but that decision depends on a number of steps. Each step would lead to different outcomes, and different outcomes they have got certain probabilities. So what you do is you construct first this whole path, that what if I do this, what are the possibilities that it could lead to, and what are the probabilities of those possibilities.
So
And
this seems stupid, no?
the decision tree,
Because how, like probability, how do you quantify?
Because
that's
there's a
the thing.
bunch.
But if you wait, hold your remarks for like 5 to 10 years,
Correct.
and then for those 5 to 10 years you study statistics, you won't be making that remark, because then your job would be calculating the probabilities and assessing how to calculate probabilities for different events, and how confident are you about your probabilities and all those sort of things. So statisticians, they have their way, but at the end of the day, a probability is a probability.
What? How are you gonna do it? Okay, for example, a car company,
Hmm.
relaunch or like
Past data, past
yeah,
data, past data,
past data of what?
past data of launches, past data of whatever activity you're about to do.
And they make a trend and then see.
What if there is no past data?
Then you look for data of other similar activities or activities by competitors.
Hmm. Nah, I disagree with
But
this.
what if you're launching the first metaverse ever?
Yeah.
What are the
Yes.
probabilities?
Yeah,
So
like diversification. How are
what's
you gonna
what's the
use it?
what's the closest that someone has ever done before, or
The new iPhone
what's
or the new Nokia that came out.
what's the crazy things that you have yourself done in the past, and what have been the outcomes?
Makes sense.
So there are ways.
No ways.
Okay. So that tells me that both of you have somehow, somewhat the idea of how these decision trees work, right?
Yes.
Need not get into too much details for this then. Where is CPA? Here is CPA. Here is CPA.
I hate CPA.
Same.
I also hate CPA.
I took ICT, and somehow we're also doing CPA and ICT as well. So I go from a business CPA class to an ICT CPA class.
Wow. So if any of you ever does project management in the future, you'll do a lot of CPS. All
When I
right.
take computer science, I think it'll come up.
Yes, it will come up. It will come up in almost any management thing that you do in future. Okay, so what you do is you first of all think of all the tasks that you can do that needs to be done for this particular project. Then you try to arrange those tasks in sequences, and for each task you draw a circle, an arrow leading to next task, and then arrows leading to next tasks, and so on, and then you assign numbers to these circles. Then you write days it takes for each task to get completed. All right.
Yeah.
Then you calculate the earliest start time first for all the activities, and then working back you calculate the latest finish time for all the activities.
You do that?
Earliest
I
start.
did. I learned it 3 times. I forgot again and
Okay.
again and again.
Okay, so here the task A it takes 1 day. So this task B and C, which is dependent on task A, they can both not be started at least 1 day into the project. The earliest you can start these two activities is after 1 day. Similarly, this task D, it depends on task B. Task B takes 4 days. Task B is dependent on task A, which takes 1 day. So 1 plus 4 is 5 days. 5 days, before 5 days into the project, you can never start task D.
Yeah.
Because the activities that it depends on takes this much time. But here it gets interesting. Task G, it depends on both task D, E, and F. So if I do
biggest one, right?
if I go by task D, it would take 7 days. If I go through this task E, it will take 19 days. And if I go through this task F route, it will take 17 days. So I will write the biggest one. Since it's dependent on all three of them, until all three of them get completed, this task can't be started. And the latest it takes all three of, the maximum time, the earliest time I can do is the maximum time for the activities in the previous tasks, and that's why I take the maximum for earliest start time.
Right.
Okay, so this way moving forward I write all the earliest start times.
Okay, now coming back.
Now going back, I calculate latest finish times. For latest finish times I'll just be subtracting the days, and for example over here, let's go to this example. So here we have got 28 days. 28 minus 2, 26 days over here. 26 minus 1 is 25, and 28 minus 6 is 22. We take the smaller one. Latest finish time, we are going backwards.
Right.
So 28 minus 2 is how much?
26.
26 minus 1 is how much?
23.
26 minus 1 is 25. The other way to get to this sixth node is 28 minus 6, which is 22.
Yeah.
So we'll take the smaller one, 22. And that is how you construct a CPA.
Wait. Now, how do you write it? I saw a question. The paper that I sent you, it has a question about CPA. It says
you have to construct one.
No, it says using CPA help redesign something. Like here, it's drive-throughs for McDonald's. But
we'll see that when we get to the paper. As of now, you should know there is a task over here.
So what are advantages, limitations?
One thing. So a few more things that you calculate using CPA is float. Total float is how much can a particular task be delayed without delaying the whole project.
Well.
That is total float for an activity. So the activities for which total float is 0, It means that if I delay this activity, it will delay the whole project.
Yeah.
Those particular line of activities, they are called the critical path. For example, task A, task B, task E, task G, and task J over here. If these were delayed, the whole project will be delayed.
Right.
And these are the activities for which we have taken the
Sir, what if
earliest and the latest.
what if over there you saw a task, I mean task I and task H. So what if both of them increase in time?
So
The
for
same
example,
task as
for
both
example,
tasks.
for each activity we can calculate the float of that particular activity. Let's do it for task H. What's the latest finish time? 26 days. What's the earliest start time? 22 days. What's the duration? 1 day. So 26 minus 22 minus 1, 23. 3. So this task H, it can be delayed 3 days and the whole project won't suffer.
Wait, can you repeat?
Latest finish time, which is 26, we are doing for task H.
Yeah.
Minus earliest start time of the previous activity, of this activity, 22. 26 minus 22.
Yeah.
Minus duration of task H itself. It's 3 days.
Yeah.
So task H can be delayed 3 days without delaying the whole project.
Okay.
And the activities which cannot be delayed at all are the ones for which we have taken the earliest start time.
Right.
For example, over here when we calculated the earliest start time, we used task E. We didn't use task D, we didn't use task F, so they are non-critical activities. Task E is critical
activity. So you
activity.
can only calculate the flow using the critical path.
The earliest start time can only be calculated using the critical paths or critical activities.
Yeah, okay.
Alright, so there are two similar things. One is called total float. How much can an activity be delayed by without delaying the whole project? And then there is free float. The free float means how much can an activity be delayed without delaying the next task. So for example, task E, it cannot be delayed at all, otherwise the whole project would suffer. We already know that. But what about task C? If I delay task C, would task F, which is dependent on it, would be delayed? Let's see. If I do task C, the earliest start time for task, this is 9. 9 minus 8 minus 1, 0. Free float is 0. Which one does have a free float? Only D and F and I. D, F and I. For D, what happens? The next activity is in 19 days. The earliest for itself is 5 days. And it just takes 2 days. So D has a free float.
Yeah.
Similarly, I and which else? G, they have a free float. So got it, these are two formulas that you need to memorize, free float and total float, and you need to know what each of them represent.
Yeah.
Okay. Okay. If you could limitations, it's just on one page. Good. Just go through this page quickly. The good thing about this critical path analysis is the whole project is before you. You get aware of all the different activities that need to be done. Number one. Then you get to know the sequence in which the activities they would be done. If you know all the activities that need to be done, it would mean no activity, it gets left out. Resources for no activity, they get left out. You'd avoid situations where in the middle of the project you suddenly realize you are short of resources. you would realize which activities are critically important, cannot be delayed at all, and which activities can be delayed at times and by how much they can be delayed. So that would help you move resources around.
Right.
Okay. The downside is that first of all, the estimate involved in how much time an activity would take is just an estimate, and the planning based on it, the critical path analysis drawn on it, would be just as good as that key estimate. That is the key estimate for different activities that we have mentioned. It depends on whether you have taken the best case scenarios or the worst case. Usually the things we should plan, I mean, while drawing things out, we should try to be as close as possible to reality instead of just giving the best case scenarios. Okay. Uh, 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 uh. Theoretically speaking, you can move resources around, but practically speaking, sometimes the resources are specialized and they can not be, I mean, as easily switched between activities as we'd like to, or as we mentioned that they can just moved around.
Okay.
Okay, else in business, resources may be inflexible. So these tasks, these activities, these critical paths that we have seen, they're for simple projects. For real life projects, and especially for projects with timelines in years and
It'll be
like
hard to.
hundreds and thousands of human and machines being involved, the more resources involved, the more the complexity of the project, the more complicated this critical paths it becomes for the project.
Yeah.
All right, all right, all right. That is roughly it. If you'd like to give it a read, you can. How about we keep it till here for today? Do you have any other like questions from the things that we have covered this far? And I'll move to index now, and you can see at all the topics and just tell me if there is anything more that you want done from the book. Tomorrow's session I want to dedicate to solving the past paper, the one that Amar sent us yesterday.
Sir,
Hmm.
we have more calculations now.
Do we?
The purple one, you can go to index and check.
Pulpal, competitiveness. Oh, ratio analysis.
Yeah,
Ratio analysis. Shall we do those right now?
we could, yeah.
Sure.
Let's do those right now. Business.
Sir, give me 1 minute, I'll be back.
Pul. Amar. Business. Okay, do I have this open over here? I don't think so. Okay.
Hello?
Hello. Alright, sir. We have got financial statements. For financial statements, the two key financial statements that we use, one of them is called income statement.
Statement.
Income statement. And the other one that we have got income statement, it's also sometimes called profit
Financial.
and loss statement. The other one is called statement of financial position or balance sheet. Statement of financial position or balance sheet. How is income statement drawn? The broad principle of income statement is revenue minus expenses is equal to profit.
Sir, which chapter is this?
This is this is Chatur Purple 17.
Okay.
Okay, the statement of financial position is broadly drawn on the principle of accounting equation, which is assets are equal to capital plus liabilities. Let's do the income statement first. The first thing that we mention is revenue. From revenue, if we deduct cost of goods sold, we get gross profit. Gross profit. If cost of goods sold exceed revenue, then we get gross loss. Okay, from gross profit, if we deduct operating expenses, then we get something called, what is it called, Mazin?
Operating expenses.
Operating profit.
Oh, operating profit. I was thinking about that.
Operating profit is also sometimes called PBIT, profit before interest and tax, or EBIT, earnings before interest and tax.
Sometimes isn't it just net profit because you don't take into account tax and interest?
Yes, if they're not there, then this is just the net profit. But if we have less finance cost, you will have profit before tax. And if you deduct taxation expense from it, you have got profit after tax. Alright,
So what is
this
COGS?
cost of goods sold.
Okay.
Alright, this is it for income statement. Shall I move to the statement of financial position now?
Yeah.
Okay. Finance cost or interest costs, usually cost of goods sold, are usually direct production and production related expenses, purchases, um, material consumed, direct material, direct labor, um, the carriage expenses for bringing the goods in, for the materials that you bought, such expenses. Okay, statement of financial position, you have got which format should I draw it in? Alright, vertical format. Sir, the first item in statement of financial position, I am saying assets. For assets, we will have two categories, non-current assets and current assets. Non-current assets include land, building, machinery, vehicles, such assets. Current assets, they include inventory, debtors, bank balance, cash, such stuff. So non-current assets and current assets, if I add them, I will have total assets of the business.
Yeah.
And on the other end, I will have liabilities. Liabilities would also be divided into non-current liabilities and current liabilities. You both know the distinction between non-current and current, right?
Yeah.
Yeah.
So this will give you total liabilities, and to total liabilities, if you add the figure of capital, Uh, Capital would include the opening capital, the profits that are earned by the business, and the drawings that they have drawn from the business. Net of all that, if you have the total capital figure, you add that, you will have total capital and liabilities. There are a few formats for the balance sheet. Sometimes what we do is we show assets minus liabilities, and that comes out equal to as capital. Sometimes we show just the sum of assets, and on the other side we show just the sum of capital and liabilities. So all these formats are correct. You just need to know that it is drawn on the principle of accounting equation. So these two amounts, they should tally. Assets are equal to capital and liabilities sum, or if I deduct from assets total liabilities, that would be equal to the amount of capital. Got it?
Yeah.
All right, moving on to the ratios that we are supposed. Okay, these financial statements on its own, they provide information about businesses, but in order to assess the performance of business, or in order to assess the position of a business, I mean, if a business has got 5 billion assets or 5 million assets, can I simply based on that comment whether the business is doing good or bad? If a
No.
business has got let's say 5 million of revenue or 5 billion of revenue in terms of dollars, can I just based on that comment whether the business is doing well or not, or the business is profitable or not? This
No.
information on its own is insufficient. So what we then resort to is what we call ratio analysis. Stakeholders, you people hopefully both already know who are the stakeholders and what's their interest in business. Should I go into that detail or not?
Not
I think we
for me.
already know, yeah.
Alright, it's just theory, you can read it from the book as well. Statement of financial position, information, these are the types of uh, intangible assets are the ones which can't be touched. Software sometimes, goodwills if you have acquired, licenses if you have any. Okay, current assets, current liabilities, non-current assets. Non-current liabilities which you'll have to pay back after a period of 1 year. Current liabilities which you have to pay back within 1 year. Okay, stakeholders interest. Let's move to ratio analysis. Alright, so first we have got profitability, and for profitability we have got gross profit and net profit margin. Okay, so the ratios that we have got are broadly categorized into two categories. One category, the first category we call profitability ratios.
Yeah.
We are trying to assess how profitable a business is. Okay, not ration ratios. The first ratio that we use is what we call GP margin, gross profit margin. Whenever we use the term margin, it means divided by sales. So GP margin will be gross profit.
Revenue. 100.
Gross profit over revenue into 100. Amar, are you following us?
Yeah. So we did this, I remember.
Alright, so gross profit margin, how do we use it? We calculate the gross profit of different businesses and we compare them, or we compare the gross profit of a business with its past periods in order to assess whether this ratio it has improved or not. Obviously, a higher gross profit margin ratio would be good. It shows that for each dollar of revenue that a business earns, it extracts more in terms of gross profit. So for example, if I have made a revenue of $500 million, how much gross profit I earned out of it? The more the gross profit, the more the GP margin ratio will be, right?
Yeah.
So how can a business, that's like how we comment on the businesses. We compare the gross profit margin ratio with its business's own past and other entities, and then there could be a question that a business's gross profit margin has decreased. Why could it decrease, or how could a business increase it? for the same revenue, if a business can charge high gross profit, if a business can somehow earn high gross profit, then its GP margin ratio would improve. How can it have the same revenue and more gross profit out of it? Uh, if they control their cost of goods sold, number one, or if they make their demand more inelastic, they'll be able to charge a higher premium on the cost for which they are selling the product, on the goods which they are selling. Right? So these are the ways, broadly speaking, two ways a business can improve their gross profit margin. The same way we have got gross profit margin, we have sometimes called what we call operating profit margin or net profit margin, OP margin. So OP margin would be same, it would now be operating profit over revenue times 100.
So they don't take into consideration tax?
So
they're planning to fraud. I get it.
We are right now doing operating profit margin. If you're doing net profit margin or profit after tax margin, we usually don't do that. I haven't seen, I can't remember ever seeing that net profit, or have I? Maybe they do.
But why would you do without tax? You have to give it anyways.
The reason is no, you have to give the tax. I'm not saying that you don't give tax. I'm saying that the ratio that we calculate, what's the difference between GP margin and operating profit margin? If you see the income statement up above here, to go from gross profit to operating profit, the difference between these two is the operating expenses. And there could be businesses which have a gross profit but which have operational losses. They have gross profit but operational losses. It means the product of the business is profitable. Either they are running their operations inefficiently, or they are yet to achieve the break-even level of sales. They haven't sold the good enough so that it becomes operationally viable as well. The good in itself is profitable, but if a business has got gross loss, they should immediately shut down, and they would shut down. It means the product of the business itself is not profitable. The way it's being produced, it's not profitable. One more thing, how could you improve the operating profit margin of a business? By controlling the operating expenses of the business. Control the salaries, introduce efficiencies, do the same procedures with like a lean structure. You'll be able to improve the operating profit margin for the business. There is one more profitability ratio which is for some reason given later on. This is what we call return on capital employed. Return on capital employed, or sometimes we just use the acronym ROCE. ROCE. Alright, so what's ROCE? ROCE is operating profit or profit before interest and tax over capital employed.
Capital employed is that
times 100.
CL.
Excellent. So capital employed, if I come up over here in the balance sheet, if I add the non-current liabilities and I add the capital, these two added together, they give me capital employed. This is sort of the funding that is available to the business, permanent funding, or at least for next 1 year this funding is secured, because you have capital and you have got these funds from non-capital liabilities which you do not have to return back in 1 year. So using these funds, how much profits or how much return have you generated?
Sir, can you show us through the worked example?
Sure. The ROCE would come in later on, or do I show you from right here? 1 second. They have shown the non-current assets, they have shown the current assets. Okay, so here they have just done the gross profit margin. So gross profit margin is gross profit 21890 divided by revenue, which is 48660 times 100. You get the gross profit margin.
Yeah.
In this
So
particular,
what is a healthy?
what is what?
What is a healthy gross profit margin?
It varies from industry to industry. Some industries, for example, for Facebook, if you try to calculate, for services industries, if you try to calculate it, it would be very high. North of sometimes 70, 80%, even north of
Yeah.
90% sometimes. Why? Because the revenues that they are generating do not require some physical, tangible stuff to be made, and using which they have to earn that revenue. And when it comes to businesses, for example, Amazon, if you take Amazon's gross profit margin would be a lot lower than that of all the tech companies. Even a very small tech company would have a higher gross profit margin than that of Amazon, because Amazon, it mainly earns, they've got two main segments, the segment of Amazon Web Services and the digital products that they sell. Obviously, they again come into the category of services or intangible products. As for these, what you call the trading activity that they do, the hub of it, like the bulk of it, that wouldn't be as profitable as, I mean, wouldn't have as high a gross profit margin as a tech company. So it varies from country to sector to sector, and varies wildly from sector to sector. So for that's one thing. So in order to assess the gross profit margin, a good point that you have raised, who you should benchmark. You should benchmark your own prior performance, or you should benchmark a business in the similar industry. In the same industry. For example, analyzing or comparing gross profit margins across industries is like not a very advisable thing to do.
What if you're like what if you're involved in multiple industries?
For each industry, you'll calculate the gross profit margin, and you'll compare that with the competitors in that particular industry. For example, you have got a bank, you have got a university that you're running, you have got a shopping mall, you have got petrol pumps. So for petrol pumps, you'll compare it with other petrol pumps. For business purpose, for internal analysis, sometimes you do that. These are the activities which are more profitable. So for internal resource allocation, sometimes you do that. You use that as well. But that again is for resource allocation. That this business, it sometimes needs, since it's earning more, maybe it should get, or it's generating more profits for me, maybe it should get more attention from me in terms of the resource allocation. Okay, then here they have calculated profit for the year margin. So profit for the year is 3940 over 48660 times 100. So they haven't used the operating profit margin, they have used profit for the year margin, which is net of interest and tax, hopefully. Alright, they have given over here current assets, non-current assets, current liabilities, and in current assets, are they inventories separate? I think they should be included in the current assets. Can you calculate capital from the given information over here? Both of you. What would be the capital of this business?
Capital?
Is it
So using this information, my assertion is that we can calculate return on capital employed. You have both noted the formula for return on capital employed. Just give me the equation. How can I what figures do I have to add, subtract to calculate a return on capital employed based on this information?
Can you write it down?
Can I write what down?
Just on the screen here. Can you write ROCE formula?
Okay, what I'll do is I'll just paste this over there.
Okay. Sir, capital employed, how is that calculated?
I told you again.
But that's using the lab. Okay, wait, it's here. I'm back.
Capital employed can be calculated in a number of ways. I'll tell you all of them once you have solved this.
No, sir, we just need one. It's fine.
No, you need all of them because sometimes in exams data is given in a different format. So here that would be helpful.
So you need to calculate something to be able to calculate something else. So the formula for capital employed is the non-capital plus capital or something like that.
Non-current liabilities plus capital I had initially mentioned.
Yeah.
Which profit would we use? The revenue, gross profit, operating profit, or profit for this year to calculate return on capital employed?
So this will be easier to do with an example.
We'd actually use the operating profit. So out of all of these, we'd be using this one, and for 2017, this one. Alright, I'll give you how we calculate the capital employed. The formula that I gave you to calculate capital employed previously was capital plus non-current liabilities. So non-current liabilities are given over here, but capital is not. How can I calculate capital? I've got assets are equal to capital plus liabilities. Assets minus liabilities is equal to capital. For assets, I've got non-current and current assets. If I add these, I get total assets. For liabilities, I've got current liabilities and non-current liabilities. If I add these two, I will get liabilities.
So capital is non-current liabilities plus current assets?
Capital is assets minus liabilities.
Which assets?
All assets minus all liabilities. So in this case, it will be 21,900 plus 5,430. This is total assets minus total liabilities, which will be triple three. In fact, tetra 3 plus 6,900. Note this down and I will give you a but.
Sir, capital employed is equal to capital plus NCL.
Capital plus NCL, non-current liabilities.
What exactly is capital?
Capital is the residual interest of owner in a business. So from the assets of the business, if I pay off liabilities, all that remains is the capital.
Okay.
So it's what the owner gets?
That's the owner's interest in the business.
Okay. Okay.
So this is how I calculate capital, and in this capital, if I add non-current liabilities, I will get capital employed, right?
Yeah. And then you can use the return on capital employed.
Now look carefully. Look carefully. I can calculate capital employed in a slightly different manner as well. Both of you look over here.
Inventories, right?
I said non-current assets plus current assets. This is equal to capital plus non-current liabilities plus current liabilities. Assets are equal to capital plus liabilities, right? Right, Amar? Do these two lines make sense to you?
Yeah.
Okay.
Capital minus liability?
No. Now this part just is the capital employed. Capital plus non-current liabilities. So if I subtract current liabilities from both sides, I will have non-current assets plus current assets minus current liabilities. This is equal to capital plus non-current liabilities, which is capital employed. So capital employed I can calculate by capital plus non-current liabilities. I can also calculate by taking total assets and deducting current liabilities from it. This will also give me capital employed. Lost?
A little bit.
I'll recap. Look over here. Assets are equal to capital plus liabilities, right?
Yeah.
Amar?
Yes.
Instead of assets, can I write non-current assets plus current assets? Would it be the same?
Yes.
Instead of capital, I just write capital, and instead of liabilities, I again bifurcate in non-current and current liabilities. Are these two lines the same, or is there any difference between these two lines?
There is no difference.
There is no difference. Now I am looking for capital plus non-current liabilities, which is
You
the
should write net assets and net liabilities.
uh, for what should I write net assets?
Like A and L.
This is okay. What I'll write is total assets.
Yeah, then it makes sense.
Total
I was
assets and
confused.
total liabilities. Net assets is something different.
Okay.
Okay, total assets is equal to capital plus total liabilities, and then I said non-current asset plus current asset is equal to capital plus non-current liabilities plus current liabilities. Agreed?
Yeah.
Okay. Now since I am interested in just this part, I want this to be on one side of the equation. I subtract current liabilities from both sides of the equation, right? So non-current assets plus current assets minus current liabilities is equal to capital plus non-current liabilities. So it means I can calculate capital employed using this, or I can calculate capital employed using this. These are both equations for capital employed since they are equal.
Asset and movement.
Got it?
Yeah. So is this just another way of doing it?
Okay, and then non-current. Okay, what is divided by this?
This is just calculating capital employed.
Yeah, what is on top?
On top, we were supposed to calculate return on capital employed. So now, if you want to calculate return on capital employed for this business, I'm given the data in the form of non-current assets, current assets, and current liabilities. So this equation I'll use. So for 2016, their return on capital employed will be 6570 divided by capital employed was how much? 21,900 plus 5430 minus current liabilities is how much? Tetra 3. This multiplied by 100 will give me the return on capital employed for this business.
Okay, what do you do with the non-current liabilities then?
See, if I use the left hand side formula, this one, I don't use the non-current liabilities or the capital because they are equal. Either I say capital plus non-current liabilities, or I say total assets minus current liabilities. It's either or, don't mix them up. and
Yeah,
we'll
there was another. There was another formula that you had told me. That's why I'm getting a little confused. I forgot what it was now.
for capital employed.
Yeah, NCL minus something plus CL, something like that.
Capital employed. Oh, are you talking about working capital?
Yeah. Okay.
That was working capital. Remember, the capital, it gets confusing. There is just standalone capital, there is capital employed, and then there is working capital.
Okay, what is all this?
Alright, I'll write the, for all three, I'll write over here. So, capital itself is just total assets minus total liabilities. Then I have got capital employed, which is either capital plus non-current liabilities, or it is total assets minus current liabilities. Alright, and the third thing that we have got is working capital, which is current assets minus current liabilities.
Okay. C is capital, right, for capital employed? Yeah.
Let me write it. Got it? These are three different equations or things in which we use the term capital, but they're all three different.
Okay.
Yeah.
And the return on capital employed, how about we resume for the ratio part tomorrow, because it's roughly been a 2.5 hour class already, and you people might have had your
Saturation period.
processors heating up. So see you both tomorrow at around 6:15 then.
Sure, sir.
Alright. Assalam.
That's all, sir. Have a good day.
Sir,